welcome to the material session of Pulsar's Career Point. This is a video for the student of class 11 on Unit 2. The name of the unit is Atomic Structure. This is the 7th video of this unit or chapter covering the topics quantum number, its different types and characteristics, and shape of different orbitals. आमे ए वीडियो क्वांटम नंबर कथा पढ़िबा, तार डिफरेंट टाइप्स कथा पढ़िबा, characteristics of different types of quantum number कथा पढ़िबा, and shape of different orbitals. Now, let us know what are quantum numbers. The constants which are used to give the complete address of an electron in an atom or to locate the position of electron in an atom are called quantum numbers. जो constant गुड़ी की व्यवहार करी आमे गुटे इलेक्ट्रॉन रो पोजीशन को एटम भितर पाई थाउ आमे ताहाको क्वांटम नंबर बोली कहि थाउ. There are 4 types of quantum number such as principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. तले क्वांटम नंबर कोन हमें जानिले जो कांस्टेंट को हमें इलेक्ट्रॉन पोजीशन को लोकेट करिया पई यूज करि था गुटे एटम भितर आमे ताको क्वांटम नंबर कोइ बोली कहि थाउ. ए क्वांटम नंबर 4 प्रकार यथा प्रिंसिपल क्वांटम नंबर, azimuthal quantum number, magnetic quantum number and spin quantum number. Let us discuss one by another the different types of quantum number. First come for principal quantum number. आमे कहा को principal quantum number बोली कहिबा. It was proposed by Niels Bohr. Principal quantum number को Niels Bohr propose करिथिले. कहा को कहिबा the constants which are used to locate the position of an electron in a cell are called principal quantum number. जो कांस्टेंट गुडी को आमे केउ सेल रे इलेक्ट्रॉन अछि जाने पे व्यवहार करि थाउ ताको प्रिंसिपल क्वांटम नंबर बोली कहा जाय. It is denoted by the symbol n. It is denoted as n. Its values, the values of n are 1, 2, 3, 4 and so on. When the value of n is equal to 1, the name of the cell is K cell. When it is 2, the name of the cell is L cell. When it is 3, the name of the cell is M cell. When the value of n is 4, the name of the cell is N cell. Thus, when the values of n 1, 2, 3, 4, then the name of these cells are K, L, M, N respectively. Now, how these quantum numbers are used? The energy of the electron in a cell is given by the formula En is equal to minus 313.65 n square kilocalorie per mole. Here Z is taken as 1. Where n is equal to 1, 2, 3, 4 and so on. So for K cell, energy E1 is equal to minus 313.65 n square kilocalorie per mole. In L cell, energy E2 is equal to minus 78.4 kilocalorie per mole. The radius of a cell is given by the formula Rn is equal to 0.529 n square angstrom. Here also Z is taken as 1. Thus, where n is equal to 1, 2, 3, 4 and so on. For K cell, radius R1 is equal to 0.529 into 1 square. That is equal to 0.529 angstrom. For L cell, 0.529 into 2 square. That is equal to 2.116 angstrom. The maximum number of electrons in a cell can be find out by using the formula 2n square. So 2n square rule is used to calculate the maximum number of electrons in a cell where n is equal to 1, 2, 3, 4 and so on. For K cell, maximum number of electrons is equal to 2 into 1 square, that is 2. For L cell, n is equal to 2, that is 2 into 2 square, that is equal to 8. For M cell, n is equal to 3. So 2 into 3 square, that is equal to 18 electrons can be present in M cell. In N cell, maximum number of electrons is equal to, here n is equal to 4, so 2 into 4 square, that is 32 electrons can be occupied in N cell. Now, let us come for the second quantum number, that is azimuthal quantum number. Azimuthal quantum number proposed by Sommerfeld. What do you mean by azimuthal quantum number? The constants which are used to locate the position of an electron in a subset are called azimuthal quantum number. Cell को जे बुझा सेला principal quantum number, जे subcell को बुझेला सेला azimuthal quantum number. How does it is represented? It is represented by the symbol N. What are the value of L? The value of L ranges from 0 to n minus 1. When the values of L is equal to 0, then the name of the subcell is S. When it is 1, the name of the subcell is B. When it is 2, the name of the subcell is D. When it is 3, the name of the subcell is F. Thus we can write down when the values of L is equal to 0, 1, 2, 3, then the name of the subcell are S, P, D, F respectively. Now, the maximum number of subcell in a cell is equal to n. गोटे सेल रे केते संख्यक सबसेल रहिबो ना सेल रो n जति के तबक सेति संख्यक सबसेल रहि फॉर k सेल n is equal to 1 so l is equal to 0 जेतु यार गोटे l वैल्यू आसिला so k cell is only one subcell which is named as 1s. For l cell n is equal to 2 so l is equal to 0 and 1, hence l is only two subcells, that is 2s and 2. For m cell n is equal to 3 so l is equal to 0, 1 and 2. For three values of L, there are three subcells of M cell. Hence, M cell has three subcells, namely 3S, 3P, and 3D. For N cell, N is equal to 4. So L is equal to 0 to N minus 1 means 0 to 3. It is 0, 1, 2, 3. It is 4 value. Hence, N cell has only 4 subcells. That is 4S, 4P, 4D, and 4M. Now, maximum number of electrons in a subcell is equal to 4L plus 2. By using this rule, we can calculate how many numbers of electrons are present in which subcell. For S subcell, L is equal to 0. So, maximum number of electrons in S subcell or S orbital is 4 into 0 plus 2, that is 2. For P subcell, maximum number of electrons is equal to 4 into 1 plus 2, that is equal to 6. For D subcell, maximum number of electrons is equal to 4 into 2 plus 2, that is equal to 10. For F subcell or F orbital, maximum number of electrons is equal to 4 into 3 plus 2, that is equal to 14. Thus, in control we have to remember S orbital can occupy 2 electrons in it, P subcell or P orbital can occupy 6 electrons in it, D subcell or D orbital can occupy 10 electrons in it, F subcell or F orbital can occupy 13 electrons in it. The energy order of different subcells or the orbital is S is less than P is less than D is less than F. As energy of 4S, for example, energy of 4S is less than 4P is less than 4D is less than energy of 4F. This quantum number describes the shape of orbitals in which electron is present. For S subcell or S orbital, it is spherical. Shape of S orbital is spherical. Shape of P orbital is a dumbbell. Shape of D orbital is a double dumbbell. And shape of F orbital is complicated and supposed to be triple dumbbell. F subcell by F orbital or safety complicated, ताको triple dumbbell बोली suppose करा है. Now, for the third quantum number, that is magnetic quantum number. Who proposed it? It was proposed by Lende. What do you mean by magnetic quantum number? The constants which are used to locate the position of an electron in an orbital or degenerated orbital are called magnetic quantum. जदि हमें Azimuthal quantum number subcell or orbital लिखी दीचु ताले हमको degenerate orbital लिखा को पड़ेगा. How does it represented? It is represented by the symbol M. The value of M, the values of M ranges from minus L to plus L through 0. Minus L to plus L through 0. For S subcell, L is equal to 0. So values of M minus 0 to plus 0 through 0 means M is only equal to 0. So it is only one orbital. So S subcell में गोटे मात्र orbital था. In P subcell, L is equal to 1. So M is equal to कितने वो ना minus 1 to plus 1 through 0. That is M is equal to minus 1, 0 and 1. Hence it is 3 orbitals, namely Px, Py and Pz. For D subcell, L is equal to 2. So M is equal to minus 2, minus 1, 0, 1 and 2. Hence it is 5 orbitals, that is dxy, dyz, dzx, dx square minus y square and dz square. For F subcell, L is equal to 3. So M is equal to minus 3, 2 plus 3 through 0. That is minus 3, minus 2, minus 1, 0, 1, 2 and 3. Hence it is 7 orbitals. That is Fx cube, Fy cube, Fz cube fxyz, fx into y square minus z square, fy z square minus x square, and fz x square minus y square. Hence the number of orbitals in a subcell is equal to 12 plus 1. By using this formula, we can calculate the number of orbitals in S subcell is 2 into 0 plus 1, that is 1. The number of um, orbitals in P subcell 2 into 1 plus 1, that is 3. Number of orbitals in D subcell 2 into 2 plus 1, that is 5. Number of orbitals in F subcell is 2 into 3 plus 1, that is 7. Maximum number of degenerate orbitals in a cell is equal to n square. Now, compare fourth quantum number, that is spin quantum number. It was proposed by Judge Arnold and Samuel Goldsmith. The constants which are used to identify the orientation of an electron in an orbital are called spin quantum number. हम ताको spin quantum number बोली कहबा. जे orientation को either clockwise orientation करूची or anti-clockwise orientation करूची. It was denoted as S. Values is plus of and minus of. The values of S is equal to plus of or minus of. When S is equal to plus of, the electron spins in clockwise direction. It is denoted as half arrow or half arrow. When S is equal to minus of, then the electron spins in anti-clockwise direction. Then it is denoted by the symbol down arrow or half down arrow. लेमने जो सिंगल लाइन टनाई थी तो हाफ गुट खाली आप एरर हाफ एरर अर्थात राइट हैंड साइड रे गुटे एरर हाफ पार्ट दिया जिवो. Otherwise we can write down up arrow and down arrow for clockwise and anti-clockwise orientation respectively. Two electrons in an orbital are represented as up arrow and down arrow or a half up arrow and half down arrow. Thus, the number of orbitals in a cell is equal to n square. Number of electrons in an orbital is equal to 2 with opposite spin. Thus, the total number of electrons in a cell is equal to n square. Shape of sp(d) orbital. For S subcell, L is equal to 0, M is equal to 0. Thus, S subcell is one orbital and the electrons are symmetrically distributed around the nucleus. So, the shape of S orbital is spherical as represented by the symbol, by the diagram. प्रथम टार में 1s orbital कथा लिखिछु. Second रे 1s आउ 2s orbital भितरे गोटे gaps अछि which is known as nodal. Shape of different S subcells are as follows. तापर हम डायग्राम टिको बनै दबा. Shape of S orbital गला एबे नजर पकिया shape of p orbital ऊपर. p orbital shape कोन हबो ना for p subcell L is equal to 1, M is equal to minus 1, 0 and 1. Thus p subcell has 3 orbitals, namely px, py and pz. The shape of p orbital are dumbbell. The shape of different p orbitals are as follows. Px means in x axis it is dumbbell in shape. Py means in y axis it is dumbbell in shape. Pz means in z axis it is dumbbell in shape. Now compare the shape of d orbitals. For d subcell, L is equal to 2, M is equal to minus 2, minus 1, 0, 1 and 2. That is d subcell has 5 orbitals. These are named as dxy, dyz, dzx, dx square minus y square and dz square. The shape of dxy, dyz and dzx orbitals are double dumbbell where the lobes are present in between the axes. The shape of dx square and dy square orbital is also double dumbbell, but here the lobes are present along the axis. And the shape of dz square orbital is just like two diffused baby suthar as shown in the following figure. dxy, dyz, dzx, dxy रे x axis y axis भितर डम्बल दिटा रहिबो, dyz रे y axis z axis भितर रहिबो, z axis और x axis भितर रहिबो. But in dx minus y square ये x axis along the x axis and y axis ऊपर रहिबो और dz square है baby suthar से. Summary of quantum numbers. Each orbital can have maximum 2 electrons and that of two opposite spin. SPDF subcell contains 1, 3, 5, 7 orbitals respectively. Maximum number of electrons in S, P, D and F subcells are 2, 6, 10 and 14 respectively. The maximum number of electrons in each principal quantum number and a principal quantum energy level is given by the formula 2n square, where n is the principal quantum number. The maximum number of orbitals in each principal energy level is given by the formula n square, where n is the principal quantum number. The number of subcells in each energy level is given by the formula n, where n is the principal quantum number. The maximum number of orbitals in each subcell is given by the formula 12 plus 1, where L is the Azimuthal quantum number. After completing this video, come for the self-assessment test 7. What do we mean by quantum numbers? Write down its different kinds. What are 4 quantum numbers stands for? What is the maximum number of electrons that can remain in different subcells? How many subcells are there in 4th cell of an atom? Designate them. Can an electron have quantum numbers? N is equal to 2, L is equal to 2 and M is equal to 2. Describe your answer. Using S, P, D and F notation, designate the orbitals with following quantum numbers. N is equal to 4, L is equal to 2, N is equal to 4, L is equal to 3, N is equal to 2 and L is equal to 0, N is equal to 3 and L is equal to 1. Arrange the S, P, D, F orbitals of an orbit in decreasing order of energy. Find out the difference between the energy values of 2 electrons present in K and L cell respectively. How is 2 electrons in an orbital be represented? Write the formula by which the maximum number of orbitals in each subcell can be calculated. Give the quantum numbers of the electron present in hydrogen atom. Which quantum number has different values for 2 electrons of helium atom? What are quantum numbers? Describe briefly the different types of quantum numbers. Thanks for watching Propulsor's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updation of my new video.